Hello, everyone, and thank you for joining. My name is Tim Conway. I am the Industrial Control System Curriculum Lead at the SANS Institute. And today I will be walking through some content in conjunction with our emerging cyber webcast in regards to the ongoing Ukraine-Russian war. If you've had the opportunity to listen to the other segments from Kevin or from Nico or from Mick, there are a number of other important topics addressed from critical infrastructure perspective, specifically on the cyber threat intel side and the open source intel side and the cyber defense elements as they would apply in a corporate business enterprise environment. But considering that a number of attacks that occur kind of gain a foothold in the stage one component of the kill chain, and then pivot their way down from corporate business enterprise into operational technology or industrial control system environments. I encourage you to navigate to the Ukraine-Russia Crisis Resource webpage at SANS and review some of those other talks. I'm going to specifically work through critical infrastructure elements, operational technology, cyber-physical components as they apply. We've done a series of other webcasts, and I would also encourage you, if you have the time, I know time is a very valuable resource currently. Most people that are working in this space and the operational tempo that is underway, finding time to kind of sit down and go through the kind of flood of resources that are available is very difficult. So we'll try to be quick here. And I'll cover some of these components specific to critical infrastructure. A number of the questions that have been coming in, Rob T. Lee had mentioned at the very beginning, one of the questions in regards to, why aren't we seeing more cyber attack? Why aren't we seeing more of a cyber-enabled component within the Ukraine war? And Rob sort of kind of addressed that specifically, but within industrial control system space, the coordinated kind of cyber physical components in Ukraine, those started in 2014 with physical attacks on the transmission system, followed by 2015 cyber attacks on the distribution system, followed by 2016 cyber attacks on the electric transmission system, and just kind of an ongoing every year, whether it's the financial sector or resources available in country to the citizens, that there's been a constant level of cyber and physical coordinated attacks that have been occurring throughout Ukraine. And as the conflict continued to escalate to the full-on war that we're looking at now, the cyber components are being used and leveraged where necessary against telecommunications and other infrastructure, but physical is the predominant approach. And again, kind of targeting critical infrastructure within country being done in a very selective way that supports strategy of the adversary nation. As we look at some of those items specifically in kind of that changing landscape of what has been occurring throughout the beginning of this conflict and special military operation and progressing into full-scale war that we're looking at today. But as we saw the attacks on the electric distribution system in 2015, and we saw those escalate to the transmission system in 2016, and Ukraine looked at kind of their dependencies and their connection to the electric system in Russia and their connection to the electric system in Belarus. And these discussions started in some forums 7 years ago, 8 years ago, and more specifically 6 years ago, kind of along the lines of Ukraine disconnecting and desynchronizing from the Russian electric system and Belarusian electric system and strengthening their ties into Poland and Romania and Moldova and connecting into those systems to participate within the European electric system, the NETSO-E system. Those discussions had been underway for a number of years, and a first time ever desynchronization plan was in place to be conducted in 2023. With the ongoing troops coming in February and starting back in June of 2021, escalation of that activity has been discussed, and a plan to desynchronized from Russia and Belarus on the 23rd, and synchronizing for the first time into the NetSOE energy market on the 24th, and operating that test model through the 26th, and ultimately remaining off of the Russian and Belarusian system from that point forward. That plan was accelerated from 2023 to occur this year. As Ukraine coordinated with Russia and Belarus to desynchronize from their electric system, occurring on the 23rd, and then prior to connecting into the European energy market on the 24th, 4 hours prior to that planned connection for the first time ever is when the invasion began. So this put the Ukraine electric system, the critical infrastructure kind of elements that have been targeted, have been a focus from Russia. It put them in a unique operating condition where they were no longer connected from Russia or Belarus, and they hadn't yet connected to the European energy system. So operating sort of as an electric island where they were creating their own generation, balancing to their own local load, and trying to balance their system that way with no capabilities to import or export and maintain some system balance through interconnections. They've been operating that way since the beginning of the invasion. And then again, that invasion occurred 4 hours prior to the planned synchronization into the European energy market. That resulted in kind of escalated calls from the transmission system operator, the electric system operator for Ukraine, to accelerate the need to connect into the European market. They have been putting out calls for that, very similar to the calls for aid to close the skies or for humanitarian support. There have been calls for additional kind of capabilities to provide some consistency during this chaos. Those calls accelerated more and more as you consider yourself in an operations perspective, trying to balance system load to generation. And as that generation is being attacked, large generation resources from coal perspectives being impacted, or as the world saw the kind of invasion and takeover of the Zaporizhia nuclear facility in southern Ukraine, and continued movement from troops to the nuclear research centers nearby, and continued movements to the South Ukrainian nuclear facility. So as an electric system operator in charge of balancing generation to load, as you're seeing generation capabilities fall into control of Russian command, then that becomes a resource that you no longer control and dispatch that you can count on. So the need for additional capabilities for import into your country are growing. So again, kind of the calls for accelerated connection to the European electric system have been ongoing since the invasion started, but they've been accelerating as different critical infrastructure targets have been being pursued further from Russia. So on March 16th, the first time ever, the Ukrainian electric system has been operating this way, operating connected to the European electric system, the NetSOE market. That connection was pursued and completed on March 16th, providing again kind of some consistency in the chaos to the Ukrainian transmission system operator. As you can see in a number of these posts, the Ukrenergo is the transmission system operator for Ukraine, and their CEO has kind of made this announcement, first time ever operating in this way, and grateful for all the supporting countries, Poland, that and other bordering countries that enabled the interconnection and operation of this way. With the full understanding that kind of in one of our previous webcasts, Rob Emley had discussed kind of the traditional back and forth with Russian adversary or Russian activity groups of kind of a tit for tat model, meaning as economic sanctions occur and the financial institutions impose restrictions and inaccessibility and kind of operating that way towards Russia, you should anticipate Russia responding with cyber attacks or targeting or something to the financial sector. In a similar way, kind of the attacks towards the critical infrastructure and electric infrastructure within Ukraine that have occurred throughout 2015 and 2016, and really going after kind of a showcase capability to show the world of a capability and an intent to use, to target and manipulate and misuse, and potentially cause damage to critical infrastructure sectors. In a similar way now, kind of thinking of these countries that are interconnected into Ukraine and providing their path to the European energy markets and are providing generation capability, providing some of that consistency in chaos. They should anticipate accelerated targeting and accelerated potential risks from Russia due to their willingness to work with and provide this capability and service into Ukraine. So that kind of brings this slide forward that we've talked about a number of ways when asset owners or business leaders or organizations or journalists ask us, what should we expect in cyber attacks from Russia? And it really becomes you can't paint that picture with one brush and one color. It depends on which sector and which country. And are you in Ukraine, where you should absolutely expect ongoing coordinated cyber and physical attacks? You should absolutely expect the attacks on critical infrastructure there will be done in whichever way is the easiest to achieve reliably, whether it's through cyber, whether it's through physical or kinetic. And the critical infrastructure attacks will be done in a strategic way that enable the invasion and enable persistence and entrenchment. Whereas if you're a country that is bordering, previously, you may have seen some cyber activity. Now, if you're an energy sector in one of those bordering countries that is providing a service and providing critical infrastructure to Ukraine, you should expect an expanded target, not just cyber positioning and information collection and access operations, but also capability development and validation, and ultimately moving towards an effects-based attack that could impact your ability to provide that critical infrastructure feed into Ukraine. And if you're a country that's further away, not directly providing that support, you should absolutely anticipate kind of the positioning and cyber validation with a achievable effects-based attack if needed as a deterrent to stop any type of aid or escalation of support to Ukraine. So again, really difficult to sort of answer the what should we expect or why aren't we seeing cyber? In a lot of ways, if you're in Ukraine, cyber is being used where it's needed. If you're in a neighboring country that is providing aid and support and critical infrastructure, you will likely start seeing escalated cyber. And if you're in a country that is kind of providing a great deal of sanctions and a great deal of kind of military support, you should absolutely expect increasing cyber presence and cyber attacks and targeting occurring. As you look across kind of the attacker objective, we'll talk about this first before we can move into the defender, where to go focus. But from an attacker side, looking at kind of causing a loss of view or loss of control so that you're making it harder to operate critical infrastructure. So things like operator human machine interface or telecommunications capabilities or field communications, impacting SCADA operations, supervisory control and data acquisition, manipulation of some type of calculations or a data feed that is required for operational decision making. So impacting situational awareness and doing that in ways that if it was done at a small scale, single site, most asset owners and operators have built redundancy into the system, have built fault tolerance, have built N-1 contingencies in place, and done it in a way where kind of a single point of failure or a single impact is not going to cause anything of significance. So from an adversary perspective, doing it at a small scale to send a signal of intent and willingness to use and a capability without burning kind of a big, well-developed, high investment tool set, but instead kind of also pursuing this as at scale and over a longer period of time, this becomes harder to operate a system when done in multiple places, not just a single strike or a single location, or a persistence that causes this effect for a long period of time where conducting manual operations or sending personnel to a variety of different field locations, that becomes very, very unsustainable from day to day to day over a long period. The next piece is on the denial side. So the denial of a service, denial of control, denial of view. In many cases, this becomes worse than the loss, meaning a loss you understand and you begin to move into conservative or emergency operations. Here you're looking at it from a perspective of things appear to be normal. And when you go to call upon a service or you go to call upon a function, that's when you discover that it is unavailable to you. And that has been denied to the operator. So there's this automatic acceleration of significance because you understand that you don't have it at the precise moment when you need it. So again, if this is done at any level of scale and for any duration, this becomes very difficult to plan around and operate around from a long-term perspective. The last piece here on the manipulation side, this is really an area that we've seen every sector kind of across critical infrastructure and across operating environments where it's not only well planned, meaning there's not a lot of thought that goes into it that's not part of exercises. It's in most cases, the big bad event that people look to is the outage. Somebody has caused a line to go down, or they've tripped off a unit, or they've opened breakers and we can no longer deliver product, or a pipeline has been impacted and we are no longer to deliver to terminal stations a product that is necessary. So looking across that outage perspective, and that's fairly well in line with what companies have always thought about due to storms and equipment failure and leaks or some type of an event that happens in the field. An outage occurs and then there's a restoration. This piece where you're looking at manipulation specifically drives you down a path of the system is up, the system is available, everything is working from a facility to the technology, but someone else is in control of it. And that someone else, without knowing their intent, you don't know if the intent is to cause an outage impacting reliability, or if the intent is to keep the system up, to misuse it, and misusing it in a way where it causes an impact to a customer, or it causes an impact to the facility or the equipment that in some critical infrastructures, that could be a 12 to an 18 to a 24-month recovery window. So now you're sort of thinking about this manipulation component in ways you never have before, meaning, do we want to keep a system up and 100% available and reliable to someone else who's in control of it and may potentially be misusing it to damage? The capability to make that decision requires data, requires a tremendous hunger for segmentation of networks, visibility into those networks, so you can see where an adversary is and potentially what they're doing and what they're able to do from that position. That can help inform and influence your operational response in regards to, is it more important to regain the integrity of the system based on what we know, or is it more important to keep the system up and operate it through an attack? As we think about those defender responses, this is an area where myself and Robert M. Lee, we looked at kind of the SANS critical controls that many would know as the SANS top 20. As you've seen those navigate over to CIS, and now in version 8, there are 18 of those controls. And we look at those and we say, similar concept, what would the controls be from an operational technology ICS environment? And what we have here is kind of the OT incident response specifically. So not taking your IT incident response plan, but taking an operational technology, operations informed incident response plan. What are the most important functions, mechanical process functions that are supported by digital assets, and those digital assets connect into operator interfaces, data servers. Those components what are the key elements that need to be defended, protected, and recovered from a prioritization perspective during an event? And what things do we have available to us? Can we move to control, inhibit, or manual operations for certain elements of the process first, so that we take the effect off the table that an adversary could achieve, and then we can start to hunt and to work through recovery of our systems while we're able to maintain operations. Having that absolute OT incident response that is focused on those risk scenarios is key. Absolutely do not simply take an IT incident response plan and assume it's going to work in your field environments. As you work through some of those incident response plans, you may discover, hey, as we build exercises and we do force on force kind of exercise and really understand some of the approaches that our system could be targeted or manipulated or accessed, we may discover that our defenses, we don't have certain capabilities. And that may be because of our architecture. It may be because we haven't built kind of necessary segmentation, or we haven't looked at architecting in a way where we're restricting inbound communications differently than we are outbound communications, or east to west communications from one plant to another plant, or kind of our supply chain access and third parties. A number of those things will drive towards a defensible architecture with the necessary kind of log collection on different devices, so you can understand how and which assets have been possibly accessed or manipulated. Really kind of understanding that and architecting it in a way where it is a defensible architecture and it can handle kind of appropriate incident response levels where certain connections can be severed that aren't absolutely essential. So it's a responsive architecture as well, where it can move into a conservative operations model or an emergency operations model with only key infrastructure available. A lot of that will be informed by OT kind of network monitoring and, you know, sort of that visibility into the process environment that for many places that may not have existed for decades. You may not have had managed switches, or you may not have had port spanning or mirroring capabilities where you can even look at the data. And then when you were able to look at the data, you may not have understood or had tool sets that understood what industrial control system protocols were. And even when you started to see some of those products come into the market, and now you could see those specific ICS protocols, understanding how that correlated to the state of the process, that may not have been super clear. So as this has been an emerging area with new capabilities coming, it is absolutely one of the areas to focus on, because you are beginning to understand what normal looks like and what baselining looks like at a cyber level that you could correspond to the process as well. Remote access, very similar in way of thinking from an IT perspective, a VPN, concentrator placement, multi-factor authentication. The key elements that I would add is just making sure you're considering all of those paths, whether it's from kind of that traditional path down for a remote support engineer, or a third party, or a vendor that's connecting in, or it's kind of site-to-site communications. All the different types of remote access components that come into play within industrial control system facilities, very important to focus on. And when it's human interactive access, it's kind of not a system-to-system communication, but it is a human providing that remote access due to an on-call support or third-party access. Absolutely pathing through multi-factor authentication and getting to a jump host environment that is kind of a trusted landing spot, that is the resource you can control and very specifically allow necessary protocols and point-to-point communication that is needed for that support. Last piece is the risk-based vulnerability management. And for this, it's really just highlighting the difference between kind of a very, very patch-centric program in an IT space, looking for vulnerabilities and addressing and patching those vulnerabilities as rapidly as possible. But in an OT space, understanding that in a lot of cases, doing that will put the operational environment at risk, and that you need to first work with vendors to understand kind of which patches have been tested, which patches have been approved, and which ones are you allowed to pursue. Then looking at an operational position of, is the risk of applying the patch greater risk to the operation than continuing to operate without it? And if you're operating without that patch, what other mitigations are in place? What additional monitoring is in place? And considering all of those things from the perspective of an OT risk-based vulnerability management program, it's not just running around and patching things, as that will likely cause more harm than not patching them in certain environments. And in other environments, it simply would not be allowed, where a system has to be validated. And then when it's up and operating during unit maintenance or plant maintenance windows, that's when a patch assessment can be done. That's when a patch installation can be done. And then a new validation needs to occur before coming online. If those are the 5 things that we would sort of guide and advise practitioners to pursue, these elements that are beneath are really kind of the foundational, what needs to exist from leadership and from an organization and from a governance perspective in order for these 5 things to be effective. And they consider sort of prioritizing which sites you would need to start these components at. What are the most important from health and safety and business and customer issues and critical infrastructure and national security, the prioritization of those sites, the alignment of what it is that you do and what are the actual risks or threats that you're facing, and aligning kind of these 5 things, which programs and which steps are you going to pursue first. One of the main linchpins is all of this from a leadership perspective and from a practitioner's perspective is being done with people and ensuring that those people have appropriate training, tools, technology to pursue their job in an adequate way. Understanding the tactical and strategic planning of how you're operating, how you're responding, and what are those prioritized sites where people are going to be deployed, and what are these 5 elements that you pursued and how they're going to inform other sites where maybe you haven't deployed sensors and network monitoring and some of these other steps because they were lower priority sites. But how can what you've done at the larger and higher priority sites inform your decision-making at the rest of your facilities? Last item on here is the vendor partnerships. And that is something within kind of OT, ICS, industrial control system environments. The marriage that exists with the vendor is absolute, meaning kind of picking a vendor that you're going to build a custom sort of, you're going to take their products and put them into a facility, and then you're going to customize the operator interface screens, the tags, the alarm packages, the kind of physics-based, how the system performs and responds, and tuning that environment, how you run it as a business. It really becomes your assets that you own and operate, and you're doing all of those tasks with a vendor's systems that they own, and driving towards we want to pursue an incident response plan for OT, and it's going to involve the vendor in this way. We're going to pursue a defensible architecture, and the vendor needs to understand how you're going to pursue that, and they may start adding capabilities for that to work. That network monitoring, who is your vendor partnered with, and who are they working with for complete kind of discovery and dissectors of that industrial control system protocol, and what does normal look like? And again, having the vendor involved in the network monitoring side. The vendor is one of the folks that are going to be coming in from a remote access perspective and doing work and doing performance maintenance tuning and potentially providing some monitoring services as well. And certainly vendor will be running a vulnerability management program of their own software and their own tools and their own systems as in line with what you're doing at your organization. Looking to what operations has done in some sectors for 100 years, looking to what you can see an operations team as they train for system events and storms and contingencies that occur. They use simulators and they have training in their schedules, and they practice the way they play, and they perform constant planning and analysis, looking at how will the system fail and what is the next greatest contingency. And they perform tasks in some sectors like load shedding, where in the electric sector, they will shed load and sever some of those connections so they can maintain a balance in the system so that they have something to recover from. And when things deteriorate too far and things occur that they need assistance and they draw upon mutual aid and others to come help restore a system from a critical infrastructure perspective, that if one part of the system is down, other asset owners and operators will also be impacted in some way. And finally, if the system collapses completely, a term used in the electric sector, black start. So when we are in a blackout condition in a certain geography or in an interconnection, you need power to make power. So there are very specific engineered and kind of in place resources throughout a service area, a control area, where you have black start capable power generation assets that will be diesel start units or hydro units, where you can use that power to start building a cranking path to the next generator that you could then start up. And you slowly start to build the system back together. Looking at every one of these operational capabilities and simply thinking about them from a cyber perspective and adding cyber to that phrase gives us things to go and pursue and target. Cyber contingency analysis, when something is attacked or when something is unavailable, what is the next most significant contingency that will impact our ability to continue to operate? From a cyber failure planning perspective, what is a significant cyber failure that would be associated to a communication path or a mechanical device that would impact operations? At what point do you move to conservative operations in your OT specific incident response plan? When you're seeing certain escalated attacks, do you stop planned maintenance, planned work, patching, signature-based updates for AV tools? When do you start to operate in a conservative model to reduce potential impacts or a problem from getting worse? Cyber load shedding capability. When do you hit a point in your incident response plan where you see an active attack coming from some part of a network or communication path that you can load shed out or sever those communications that are not necessary for absolute critical operations? From a cyber black start perspective, if asked any entity, do you do backups and do you have restoration plans? Of course. We do, parent, child, grandparent, full differential incremental plans. We test restoration once a quarter. But from the perspective of a cyber black start thinking, which cyber assets do you need in order to do restoration and recovery of cyber assets? So in order to regain capability of cyber assets, what other cyber assets do you rely on for that? And if they were unavailable due to a firmware attack or due to a BIOS attack or something that made the cyber asset unavailable that you use to restore to other cyber assets, do you have a concept of an offline system? Do you have a concept of a spare tire system that has minimal functionality that will allow you to do the core operational components if you have a complete cyber impact across a facility or an environment? The last element, cyber mutual aid. In some sectors, that's a legitimate goal from a perspective of cyber defenders from one company helping cyber defenders at another company after an attack. For other sectors, that doesn't exist. So you're looking more towards managed services or incident response capability from companies. You may be looking to ISACs, information sharing and analysis centers, or CERTs, where you may be able to gain some support and assistance. Ultimately, we need to get past operating in silos, from field environments to operational control centers with IT and OT kind of in the middle, and IT and OT not really working well together. Absolutely pursuing kind of joint exercises where they're working together as a team and responding to an event or a sequence of events or a force on force type of exercise with an adversary emulated, so you could really respond the way you would as an organization, as a critical infrastructure sector, as a team in response to events that occur. This closing slide here on operational response, I've talked a lot about the specific capabilities necessary from a industrial control system perspective in an OT environment, looking at you may not have yet the logging. You may not have yet the OT network visibility. And sort of, if an attack happened tomorrow and you had an OT specific incident response plan, you would need to build that based on your current capabilities. And you may need to rely on operator tools and sequence of events and alarms that occurred and system events that occurred as an identification phase. And then based on that identification, you could look from a containment perspective to say, if an adversary achieved the following effect in our system, where would they have had to have been to do that? And then begin to sort of contain and work through that capability where you can isolate the system or isolate the control, move to a control inhibit model or a manual operation model while you continue to investigate that so you can operate your system through the attack, ultimately working towards eradication and recovery. And kind of taking this model and adjusting it where you have capabilities. So if you have a defensible architecture, how will that inform your identification capabilities from additional logs, from additional kind of defense positions, and into the containment side as well? You know, in the identification phase, if you have OT network monitoring, do you have playbooks that would move you towards containment and escalation of an operating model from normal operations to conservative operations to emergency operations that is in line with your OT incident response plan, ultimately moving you towards kind of an eradication, recovering the individual assets and the capabilities, ultimately with a goal of ensuring you have integrity of the control system. That I would just reference again the resources that are available for the Ukraine cyber crisis, that a number of other webcasts have been delivered. There's a number of documents that are out there and available, and I would encourage you to pursue those as time allows. I greatly appreciate you joining me for this session, and I hope to see you in person soon, or if you have any questions, please send them to tconway@sans.org. I'd be happy to connect with you on a call or work through any outstanding questions you have. Thank you again for joining.